This is SpaceTime Series 24, Episode 64. Coming up on SpaceTime, 2 new missions to study the planet Venus, the Australian Square Kilometre Array Pathfinder's first glimpse of the Galactic Plane, and Mars Ingenuity experiences an in-flight failure. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has selected 2 new missions to explore the planet Venus. The missions, known as DAVINCI Plus and VERITAS, will help scientists better understand how Venus became the nearest thing to hell in our solar system. Earth's nearest planetary neighbour, Venus, is often called Earth's sister planet. And there's good reason. Both worlds are about the same size. Both were formed in the same part of the solar system at about the same time, under similar conditions, and from the same materials. But if Venus is Earth's sister planet, then it's a twisted sister. Venus has evolved into a hellish world, blanketed by a thick poisonous cloud cover, where surface temperatures are hot enough to melt lead. Surface air pressure is 99 times greater than that on Earth, and where it rains sulfuric acid and metallic snow covers the mountain peaks. How did Venus get that way? Well, the 2 new NASA missions are aiming to find out. They'll launch sometime around 2028 to 2030. The Deep Atmosphere Venus Investigation of Noble Gases Chemistry and Imaging, or DAVINCI mission, will measure the composition of Venus's atmosphere in order to better understand how it formed and evolved, as well as determine whether the planet ever had an ocean. The mission consists of a descent sphere which will plunge through the planet's thick atmosphere, making precise measurements of noble gases and other elements in order to understand why Venus's atmosphere has become such an extreme runaway greenhouse effect. In addition, DAVINCI will return the first high-resolution images of unique global geological features on Venus known as tesserae, which may be comparable to Earth's continents, which would suggest that Venus has, or at least had, plate tectonics. DAVINCI will host a compact ultraviolet and visible imaging spectrometer, which will make high-resolution measurements of ultraviolet light using a new instrument based on freeform optics. DAVINCI Plus will be the first US-led mission to Venus's atmosphere since 1978, and the results could reshape science's understanding of terrestrial planet formation in our solar system and beyond. The second mission is called VERITAS, the Venus Emissivity Radio Science INSAR Topography and Spectroscopy mission. VERITAS will map Venus's surface in order to determine the planet's geologic history and try to understand why it's developed so differently compared to that of the Earth. Orbiting Venus with a synthetic aperture radar, VERITAS will chart surface elevations over nearly the entire planet, creating a 3-dimensional reconstruction of the planet's topography and confirming whether plate tectonics and volcanism are still active on Venus. VERITAS will also map infrared emissions from Venus's surface to identify its rock type, which is largely unknown, and determine whether active volcanoes are releasing water vapor into the atmosphere. Combined, these 2 missions will help scientists better understand exactly how such an Earth-like planet could become such a hellish environment. This is SpaceTime. Still to come, the Australian Square Kilometre Array Pathfinder gets its first glimpse of the Galactic Plane, and the Mars Ingenuity helicopter experiences an in-flight failure. All that and much more still to come on SpaceTime. Astronomers have used the Australian Square Kilometre Array Pathfinder, or ASKAP, to develop the most detailed map yet of a portion of the galactic plane of the Milky Way. The findings, reported in the monthly notices of the Royal Astronomical Society, measured almost 4,000 compact radio sources, many of which were unclassified, as well as regions of ionised hydrogen where star formation's taking place. The galactic plane's always been one of the essential objectives for astronomers, as it's the part of the galaxy where our own solar system resides. and it contains billions of stars, as well as dust and gas clouds, and presumably dark matter. The project was part of the stellar continuum originating from radio physics in our galaxy, or Scorpio, survey, which itself is part of EMU, the Evolutionary Map of the Universe program. The project's been difficult because of the huge amount of emissions emanating from so many different sources in this very busy part of the sky, making it challenging to obtain artifact-free images and effectively reducing the quality of the final images, which in turn make data analysis more challenging. Adding to the difficulty, at the time the observations were carried out, ASKAP wasn't yet fully operational, with only 15 of its 36 12-metre parabolic dish antennas deployed. Still, it allowed the radio telescope interferometer to image an area of the sky covering about 40 square degrees. Astronomers were still able to study many sources once referred to as radio quiet, and they discovered numerous extended unclassified sources belonging to a class of galactic bubbles, constituting a new sample for identifying supernova remnants. Located in the Murchison region of outback Western Australia, some 800 kilometres north of Perth, ASKAP is one of the technology demonstrators set up as part of the lead-in to the giant Square Kilometre Array project, which is building the world's largest radio telescope spanning Australia and South Africa. The new ASKAP observations of the Galactic Plane will allow astronomers to explore a whole new series of astrophysical processes, which could lead to the discovery of a new class of object. The unprecedented sensitivity and angular resolution of these and future EMU observations is allowing astronomers to study galactic structure and stellar evolution in far greater detail than ever before. And the EMU project doesn't just cover the southern hemisphere. It extends into the northern hemisphere as well, covering some 75% of the sky at frequencies of around 1 gigahertz. EMU project lead scientist Professor Andrew Hopkins from Macquarie University says the data taken during this early stage of ASKAP commissioning demonstrates the interferometer's extreme sensitivity to extended radio emissions, allowing the detection of important structures in the Milky Way and providing new insights into the formation and evolution of its stars.
EMU is an ambitious project. We anticipated being able to use the new ASKAP telescope as it was in its design stages over 10 years ago now, to be able to map the entire southern hemisphere to depths and resolutions that had previously only been able to be made over a few square degrees of sky. So we expect that EMU, when it's fully complete in perhaps 5 or so years from now, to be providing the best map of the entire hemisphere at radio wavelength to enable science that spans not only an understanding of galaxies like our own Milky Way and how they've evolved over the history of the universe, but also the galaxy itself, the Milky Way galaxy, and the detailed properties of star formation regions within it, supernova remnants, the end stages of star formation, and all the way through to cosmology, the study of the properties of the universe itself. So it's a very wide-ranging and ambitious project. The data volumes are going to be huge. We expect to detect anywhere from 30 or 40 million up to maybe 70 million radio sources in that project. That is more than an order of magnitude, and in some cases approaching 2 orders of magnitude over the total existing number of radio sources ever measured to date by humanity. So it's a very exciting project, and we are already starting to see some of the tantalising hints of what that excitement looks like from the early science phases of the project that we've been able to do with the ASKAP telescope, and more recently the pilot surveys that we've started to get data from.
And part of this involves looking through the galactic plane. Difficult because it's oozing with radio sources.
Yeah, exactly. The Milky Way, the galaxy that we live in, has many mysteries that, of course, astronomers have been progressively uncovering over the last few decades. But one of the challenges is understanding the properties of the way the stars in the Milky Way have formed, how they evolve, how they end their lives. From the perspective of a radio telescope, we get a great insight into both the early stages and the end stages of that star formation process. The early stages are illustrated through the hydrogen gas clouds that the stars form from and which produce radio emission, but also the supernovae that the most massive stars end their lives with, incredibly spectacular events, leave a signature of an expanding gas ring, which again we can detect at radio wavelengths. And picking out these hydrogen gas clouds and supernova remnants, as well as other unusual stars that relatively rare produce their own radio emission directly from the stellar processes going on in them as they evolve, really opens up the window on how we get a handle on the way that the Milky Way itself has changed over its history. One of the projects that we're doing as part of EMU is a project called Scorpio. This is being led by a team of Italian astronomers. Grazia Imana and Simona Righi are the two team leaders, and work that they have just recently published shows the power of the ASKAP telescope in being able to open this window for us on the properties of the Milky Way. It's only the tiniest little snippet of what we're going to see in the eventual EMU survey, but it has already delivered a wide array of new and exciting results, including discoveries of new supernova remnants, as well as new hydrogen gas clouds, among other exciting results. And these are results that were obtained using data taken even before ASKAP was fully operational. ASKAP itself has 36 radio dishes, antennas, and this data was taken when only 16 of those were being used as part of the early science verification test. But even so, it's already demonstrated that we're able to do some fantastic science and learn new things about our own galaxy.
As you peered at the universe using ASKAP, were you able to see things really close to home or anything's a long way away? I guess what I'm asking is, are we currently going through the local bubble? Can you see the edge of the local bubble, or is that too close for resolution? Assuming the local bubble's a supernova remnant, I guess.
I think when you get to the very, very faint and diffuse levels of emission, it is very challenging. ASKAP is one of the best instruments that's ever been developed for measuring the combination of faint diffuse emission at relatively large angular scales. So because it's an interferometer, it's not sensitive to the emission on the very largest angular scale, but because it has a very small shortest baseline compared to many other radio interferometers that astronomers have been using for many, many years, it actually does a lot better than most of those other facilities have been able to, without the need to use additional data from single dishes like the Parkes Radio Telescope, although we're also planning to take advantage of that as well. So the sensitivity on those largest angular scales to that very, very faint emission is very, very good. What that means is that we're able to pick up the complexities in extended structures like the shells of emission from supernovae in the galaxy. In terms of the superbubble itself, I defer on that to some of my more expert colleagues who are working on that. But in the context of the other part of the question that you asked, we're able to pick up interesting structures from the very nearest parts of the universe in terms of the Milky Way itself through to the most distant parts of the universe. We're already detecting galaxies that have supermassive black holes at their cores that are likely to exist at the very, very earliest periods of the universe's history, maybe as early as a few billion years after the Big Bang. So we're really spanning the whole range of the universe from the nearest to the furthest.
What part of the galactic plane did this current survey look at?
It looked at a region in the constellation of Scorpius, and this region was chosen because it had a series of known radio sources that we were very interested in exploring, and it was also the subject of a precursor experiment using the Australia Telescope compact array, the interferometer at Narrabri in northwestern New South Wales. And that compact array image covered the same area of sky, but not to the same level of sensitivity and resolution that ASKAP was able to provide. The compact array image was also taken at a different frequency, a different radio frequency, a slightly higher frequency than was used in the ASKAP observation. And the combination of the information at those two different frequencies adds additional value in the way that we can understand the properties of the radio sources being measured. So it's a particularly interesting and valuable patch of sky. we're actually planning to extend the region of sky around which that original ASKAP observation was taken when we begin our next stage of pilot observations in just a couple of weeks' time, in fact, hopefully, as well as covering a number of other patches of the extragalactic universe to understand a little bit more about the performance of the telescope before we begin the main survey operations towards the end of this year or early next year.
I understand there's been some getting used to the way the telescope operates, looking at that particular part of the sky, because you're not looking at very diffuse areas. You're looking at a very busy environment, looking towards the Galactic Centre.
Yes, exactly. And it's always been a challenge for radio interferometers to produce very high fidelity images when you have very complex and bright emission on a range of different physical scales. So one of the challenges that we've been working through with ASKAP is to understand how we can ensure that the telescope's performance when observing these very complex parts of the sky gives us the best possible images. And we're still not quite there yet, although we think that we're doing a lot better than we were able to even with that early science data. But there's still some way to go, I think, and part of the goal of our next round of pilot observing that I just mentioned will be to understand exactly the kinds of processing that we need to do to improve the fidelity of the images as a result. This is a particularly challenging area for radio astronomers. It's an area that has required a lot of fairly sophisticated computational development, and it's something that is applicable not only to ASKAP but to the rest of the generation of pathfinders for the SKA and ultimately to the SKA itself. So while we're doing some interesting and exciting science in its own right, we're also really paving the way for the next generation telescope, which is going to be absolutely fantastic.
The survey found some, 4,000 radio sources of interest. Any surprises there?
No, not at all. One of the things that is really exciting about astronomy is that every time you take an image, you get an amazing set of new and exciting data. The numbers of sources that we've identified in this particular patch with a Scorpio observation is about the number that we expected. Many of them are being detected for the first time, although we could make predictions for the numbers. This is the first time that they've been seen. And, of course, when you see things for the first time, you learn new things about the universe. And so it really is helping to open a window on the properties of the galaxies that we're seeing through the Milky Way, behind the Milky Way, as well as the object within the Milky Way itself.
A couple of years ago, the Event Horizon telescope, or more accurately, the Event Horizon interferometer, grabbed a stunning image of the shadow, for want of a better term, of M87, the black hole at the centre of that galaxy. That was one of its stated goals. The other goal was achieving the same sort of image of Sagittarius A star, the black hole at the centre of the Milky Way galaxy. However, that's proving to be a bit more difficult for that team. Is this the sort of thing that ASKAP could help out with?
Yes, absolutely. The way that data is processed is to bring measurements from a series of radio telescopes around the world together and to combine it offline rather than online and in real time. And the ASKAP telescope would be ideal for being able to contribute to those kinds of experiments for sure. It's a technique called very long baseline interferometry, which means bringing data from telescopes at very, very great distances from each other together and correlating the measurements from all of those different telescopes together to produce those incredibly high resolution images. The further apart your telescopes are, the higher the resolution that you can get. And of course, you're ultimately limited by the diameter of the Earth, but the greater the sensitivity that each of those telescopes have, the better or the more sensitive you are to fainter signals from those tiny, tiny objects, such as that ring of emission, the shadow, the echo around that black hole. So yes, it's one of many, many things that ASKAP is likely to be able to contribute to. I've been talking about the EMU survey, which is the one that I've been leading together with a team of about 400 or so people around the world. So it's a very large team. It's a very ambitious survey covering a wide range of science, as I've mentioned. But it's only one of many, many things that ASKAP is planning to do in its first 5 years of full operations. There are half a dozen other surveys that ASKAP is expecting to deliver over that time frame that will explore everything from the detailed properties of gas in nearby galaxies to time variation of astrophysical objects. So things like fast radio bursts or the scintillation in the gas within our own galaxy that makes objects seem to flicker and vary with time. There's a whole range of different projects. I can barely touch the surface of them in a short interview like that.
Are you concerned about Starlink?
Absolutely. All astronomers worldwide are.
It's becoming a question I'm asking every astronomer.
The more airtime this issue gets, the better. And the more Elon Musk hopefully will sit up and take notice, together with the various other programs. Starlink is perhaps the most notable one at the moment, but it's not the only one. 1,700
satellites and growing.
It's a phenomenal project in its own right, and it's incredible. But for astronomy, it's an incredible challenge and has significant negative impact. In fact, I think the NASA picture of the day showed the famous Orion Nebula taken, and because you need to take long exposures to get those very sensitive images, you can see the trails left by the satellites that absolutely mar the image in ways that are horrific if you're trying to do any kind of sensitive measurements of the sky. It's a challenge at radio wavelengths as well. So the optical images, there's a very, very clear negative impact. At radio wavelengths, the satellite constellations are using those radio frequencies to communicate with Earth, and it causes massive, massive problems for us. So, for example, the primary band that the ASKAP telescope observes in at around 1.4 gigahertz has almost half of the frequencies around that central range wiped out by satellite communications. So it is a constant challenge. Obviously, the satellites are delivering valuable resources for humanity, and that's something that we want to be able to continue to support and to see being developed. But it would also be nice to be able to continue to do the science that we want to do to understand the universe and our place in it. And finding some happy medium to allow both to coexist is going to be critically important.
That's EMU project lead scientist, Professor Andrew Hopkins from the Macquarie University in Sydney. And this is SpaceTime. Still to come, NASA's Mars Ingenuity helicopter experiences an in-flight failure and an annular solar eclipse to take place on June the 10th. All that and more still to come on SpaceTime. NASA's Mars Ingenuity helicopters experienced a major whoopsie, oscillating back and forth out of control until finally landing following its latest flight on the Red Planet. The test flight on the 91st Martian day or SOL for the Mars Perseverance rover mission was the sixth flight for the 1.8 kilogram rotorcraft. The flight was designed to expand the helicopter's flight envelope, taking stereo aerial images of a region of interest to the west. The flight plan called for Ingenuity to climb to an altitude of 10 metres before heading 150 metres to the southwest at a ground speed of 4 metres per second. It would then change its heading, flying south of 15 metres while taking images towards the west, and then fly another 50 metres northeast and land. At least that was the plan. However, 54 seconds into the flight, at the end of the initial leg to the southwest, Ingenuity began adjusting its velocity and encountering roll and pitch excursions of more than 20 degrees. The tissue box-sized twin-rotor aircraft is designed to keep track of its motion while airborne using an onboard inertial measurement unit which records its acceleration and rotation rates in order to determine where it is, how fast it's moving, and its spatial orientation. Ingenuity's onboard control system then reacts to this data by adjusting control inputs some 500 times every second. Ingenuity is also using its navigation camera to support the inertial measurement unit by providing a bigger picture view of where it is and what it's doing. The downward-looking navigation camera takes 30 pictures per second of the Martian surface and then feeds that data to the helicopter's navigation system, which then compares each image to the previous image and works out where it should be according to the inertial measurement unit, and then makes adjustments accordingly, correcting its estimates of position, velocity and attitude. It's designed as a fail-safe system. Mission managers say a glitch in the pipeline of images being delivered by the navigation camera caused one image to be lost and consequently resulted in all later navigation images being delivered with inaccurate timestamps. and that caused the navigation algorithm to assume it wasn't where it's meant to be and perform a series of corrections based on the wrong navigational images. The chopper eventually made a safe if somewhat bumpy ground landing about 5 metres off target. This is SpaceTime. Still to come, an annular solar eclipse of the Sun, visible from Canada, Greenland, the Arctic Ocean and Siberia. And later in the science report, new research shows that mixing AstraZeneca and Pfizer COVID-19 vaccines produces a stronger immune response than sticking to one type or the other. All that and more still to come on SpaceTime. An annular eclipse of the Sun will take place on June the 10th, visible from Canada, Greenland, the Arctic Ocean and Siberia. In the United Kingdom and Ireland, observers will see a partial solar eclipse with up to 2/5 of the Sun blocked out by the Moon. Normally during a solar eclipse, the Sun, Moon and Earth are all perfectly aligned so that the Moon would pass directly in front of the Sun as seen from Earth, in the process blocking out the face of the Sun completely. That's because, thanks to a quirk of fate, although the Sun is 400 times bigger in the sky than the Moon, it's also 400 times further away. So from here on Earth, they both look to be the same size. However, the Moon's orbit around the Earth isn't completely circular, but rather elliptical. And so there are times when the Moon's orbit places it further away from the Earth, and therefore makes it appear to be slightly smaller than at other times. And when a solar eclipse happens during this period, such as now, the Moon doesn't cover the entire face of the Sun, instead resulting in an annulus at mid-eclipse. Observers along the narrow track of annularity will see a bright ring of sunlight around the silhouette of the Moon, a spectacular ring of fire. The track will begin in Canada, north of the Great Lakes, before crossing northeastern Canada into the Arctic Ocean, then passing over the North Pole, and finally ending in northeastern Siberia. Now, observers at these locations will see up to 3 minutes and 51 seconds of annularity, with about 9/10 of the Sun covered by the Moon. Now, away from the exact path of annularity, the Sun will only be partially obscured by the Moon. And this partial eclipse will be visible across most of Europe, Northern Asia, the UK and Ireland. Observers of the partial eclipse will see a crescent Sun as the Moon passes between the Sun and the Earth. Although annular and partial eclipses of the Sun are spectacular events, they should never be viewed with the unaided eye. Even though a large part of the solar disk will be covered, looking at even a partially eclipsed Sun without appropriate eye protection will cause serious and permanent damage to your eyes. Use only eclipse glasses. Anything else will be too dangerous. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that vaccinating people with both the Oxford AstraZeneca and Pfizer BioNTech COVID-19 vaccines produces a stronger immune response against SARS-CoV-2. A report in the journal Nature claims preliminary results from a trial in Spain of over 600 people showed significant benefits of combining coronavirus vaccines. The World Health Organization now estimates some 8 million people have been killed by the COVID-19 coronavirus, with over 3.6 million confirmed fatalities and more than 172 million people infected since the deadly disease first spread out of Wuhan, China. Scientists have formally relaxed long-standing regulations which limited research on human embryos to no longer than the first 14 days after conception. The International Society for Stem Cell Research has released the updated guidelines, which include relaxing the so-called 14-day rule, which previously prevented scientists from carrying out research on human embryos in the lab beyond the initial 14 days. Since the last guidelines were issued in 2016, the authors say there have been major developments in stem cell and human embryo research, including genome editing, stem cell-based embryo models, and human-animal hybrid embryos known as chimeras. One of the major changes in the new guidelines is that all research involving the growth of human embryos, including that going beyond 14 days, will now be subjected to a review and approval process through a specialised scientific and ethics review. The guidelines also recommend that any application for research beyond the 14 days should also be subjected to public debate prior to the review process taking place. The International Atomic Energy Agency has raised fresh concerns over Iran's undeclared nuclear activities after the Islamic Republic restricted the movement of UN weapons inspectors and has continued adding to its existing enriched uranium nuclear stockpile. Tehran has now suspended inspections at several key nuclear sites. It's also accelerated its nuclear enrichment program, both in clear violation of its 2015 nuclear non-proliferation agreements. The UN nuclear watchdog is especially interested in 3 sites where recent undeclared nuclear activity was being undertaken and a 4th site where a uranium metal disk had been stored. These disks are only used in nuclear weapons, and so producing or acquiring plutonium or uranium metals or their alloys is another clear violation of the 2015 Vienna nuclear deal agreed to by Tehran. Meanwhile, the Islamic Republic's stockpile of enriched uranium now stands at some 3,241 kilograms. That's around 16 times the limit originally laid down and agreed to in the 2015 deal. The latest nuclear violations by Iran follow last month's warnings by both German and Swedish intelligence agencies of growing efforts by Tehran to obtain technology needed to build nuclear weapons. In its April 29, 2021 report, the German intelligence agency warned that the Islamic Republic had not ceased its drive to obtain weapons of mass destruction or the products used for their manufacture, as well as the nuclear missiles needed to deliver them. The agency found Germany remains a focus of Iranian espionage activities, with well over 1,000 known members of the Iranian-sponsored Hezbollah terrorist group operating in Germany. Meanwhile, Sweden's 2020 Security Service Intelligence Report also warned of Iranian efforts to seek Swedish nuclear weapons technology, targeting Swedish high-tech industries and products which could be used in nuclear weapons programs. It warns that the Islamic Republic of Iran, together with China and Russia, remain Sweden's biggest security threats. The Swedish and German intelligence reports come in the wake of multiple warnings by the United Nations that Iran is continuing to accelerate its nuclear activities, starting up new cascades of 124 IR-5 and IR-6 centrifuges, thereby allowing Tehran to dramatically increase its production rate of enriched uranium. The centrifuges enrich uranium by rapidly spinning uranium hexafluoride gas, separating out the fissile uranium-235 from the non-fissile uranium-238. Iran's also continuing to develop and test nuclear missile systems under the guise of a space program. Tehran's developing a parallel long-range nuclear missile delivery system in collaboration with North Korea, which also developed its nuclear missile program under the cover of being a space program. In February, Iran successfully launched its Zholjana-1 rocket on a suborbital trajectory. Importantly, the rocket, which uses a solid-fueled first and second stage, was designed to be flown not from a conventional launch pad, as you would in a space program, but rather from an Army mobile missile launcher, a system used exclusively for tactical and strategic weapons. A new study shows that men really do think with their, well, let's just say it's not their brains. The new study in the Journal of the Royal Society Open Biology found that tissues that make up the testes and the brain share numerous molecular features and produce many of the same proteins. However, the common proteins are mainly involved in development, the movement of material within and between cells, and brain-associated biological processes. But still, even in terms of their activity, the two organs share many characteristics. The author suggests the involvement of both the brain and, shall we say, family jewels in the evolution of new species may well explain the similarities. It's been revealed that the British are obsessed with UFOs, and especially with aliens. A new study shows that people in the UK do more internet searches about aliens than any other European country, an average of 624,000 searches relating to aliens every year. Tim Mendham from Australian Skeptics says that puts the Poms well ahead of the French and Polish, who filled the second and third spots on the UFO interest list.
The story goes that people in the UK do more internet searches about aliens than any other European country. One of the key things they're trying to find out is what do they look like? What do aliens look like? Last year, 624,000 searches, which is 1,710 Google searches a day. Second is France, only 408 searches. And third is Poland. The main things they're looking at is what would an alien look like? How do aliens contact us? What are aliens? Where are the aliens? And why on earth would they come to us? And so that's the main reasons that people are looking for, which are all reasonable questions, actually, that skeptics would ask as well. We might not get the same answer as some other proponents, but if the people of Britain are doing that, you could actually suggest they're more skeptical by doing more research, which is a good thing, or they're more believing and are just looking for support for their beliefs, which is not a good thing. But you also got to look at population densities and that sort of stuff. Some of the figures might be a bit chonky
as well, things like that.
Yeah, that's right. But you also might look at population size and all sorts of things and the sort of TV programs they have on. So, it's an interesting study.
Let's be honest, a lot of it's to do with how well off a country is. If you're struggling to survive, you've got more important issues to deal with than what aliens look like, let's face it. But if you're in a reasonably comfortable country, one with a high standard of living, these are the sort of things you may ponder about.
Yeah, this is a first world issue, obviously, that, people who think, I'm okay, I've got my job, I'm looking after this, now let's get on to the serious issues. So it is probably a sociological study in there somewhere.
Oh, yes.
But based on these figures, I think I'd be a bit wary, actually.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.